Buildings are getting taller and elevators are going faster and faster. We are in an elevator speed war. I'm at an elevator manufacturing plant and test center where they designed the world's fastest elevator going 1,260 meters per minute, approximately 47 miles per hour. Right there is the test center, the G1 Tower. In a world where we move mostly horizontally, cars, trains, planes, we're going to be looking at the limits of moving vertically.
Only in Japan. 2004, Taipei 101, the world's tallest at the time, had the fastest elevator at 16.8 meters per second, 1,010 meters per minute, or 37.7 miles per hour. 2017, Shanghai Tower, 632 meters or 2,073 feet. An impressive building of glass and steel with an unusual shape overtakes Taipei 101 with an even faster elevator at 1,230 meters per minute, 20.5 meters per second, or 45.9 miles per hour, winning the new Guinness World Record for their team. 2019, the 530-meter, 1,740-foot Guangzhou CTF Finance Centre in China unseats the Shanghai Tower, going 1,260 meters per minute, 21 meters per second, or 47 miles per hour. All three of these fastest elevators are produced by Japanese companies, the speed record dominated by Japanese manufacturers since 1978. And 3 of the top 10 elevator manufacturers in the world are Japanese, so if you want to go fast, we're going to the right place. As the reigning elevator speed champion, we'll learn the challenges the Hitachi team overcame to break the speed record, and what it'll take to go higher, faster. The testing was done in the tallest structure on the horizon in this part of Japan, the G1 Tower, engineered for testing the world's fastest elevators in the tallest skyscrapers. Safety and comfort are essential parts of the challenge. Constructed in 2010, it's 213 meters, 699 feet high. The team's hard work led to passing a rival company to earn the Guinness World Record with that number, 1,260 meters per minute. Japanese companies have been pushing the speed limit for decades, overcoming many challenges. The speed war is also a practical one with safety and comfort a necessity. With talk of going over 50 miles per hour and elevators to space, which we'll discuss, I got to the point with Hitachi's project manager, Abe-san. Can they go faster?
一方でこれ以上速くすると人間がですね、今度乗ってるお客様がちょっと耐えられなくなるということがあります。ですね、そういうお客様のそういういわゆるなんですかね、耳詰まりに対してはかなり厳しいレベルにはもうなってくるかなとは思います。はい。
The most obvious hurdle isn't how fast the elevator can go, but how fast the human body can go vertically, comfortably. The higher humans go, the more the pressure changes. The team solved this in the world's fastest elevator.
気圧調整装置といいまして、カゴ自体の密閉度を高めて、でカゴが移動するために、圧力が変化していっちゃうわけですね。高度が高くなれば圧力下がってきますけれども、気圧ですね、気圧が下がっていくのに、その変化の度合いをですね、緩和するようになんだろうな、ポンプのようなものがついていて、で空気を入れたり抜いたりして。
It works like a pump, adding and removing air automatically, so riders don't notice the air pressure change as much. So they could reduce that discomfort, but this was only one of the many other challenges to overcome, including shaking, vibrations, and noise. The taller a building gets, the faster it could go. There are limits, but design can extend or push those limits. Hitachi is also a manufacturer of high-speed trains in Japan. The group can draw on the horizontal engineering knowledge to solve challenges like elevator speed. And the design of the world's fastest elevator is shaped similar to a train to reduce shaking and noise with improved wind resistance, even when passing the counterweight. This means they can go faster without forfeiting comfort and safety.
エレベーターのロープがですね、ビルが高くなるとロープの長さも長くなるんですけど、ロープ自体も重いので、どんどんそのロープ自体が支える強度が必要になってきちゃうんですね。その代わり自分が重いと結局自分の持つための強度が必要になってくるんで、どんどん飛躍的にこうロープが重くなっちゃうんですよ。
To make a super fast elevator, you need the distance to reach a top speed, but more distance means more rope, which means more weight. A stronger rope, a stronger generator to pull it half a kilometer to the top, fast and safe? It's a real R&D challenge. Innovations in making ropes stronger and lighter have also allowed the team to push to new heights and speeds. How about elevators to space? A Japanese company has a concept that can become a reality with new materials like carbon nanotubes, which could be that answer to take elevators to space. This video, courtesy of Obayashi Corporation, is their concept elevator based on carbon nanotube technology, which doesn't seem too far off in the future. Sci-fi meeting reality. Elevators have the potential to go beyond the sky. With an Earth port anchored out at sea and an elevator counterweight 96,000 kilometers, nearly 60,000 miles away, it could have stations or gates going to the moon, to Mars, or other space tourism adventures. The possibilities are fantastic to think about. But let's get back down to Earth. Japan's tallest building from 1993 to 2014 was Yokohama's Landmark Tower, which also had the world's fastest elevator at the time. It's 296 meters, 971 feet. It reaches 750 meters per minute going up, only 40 seconds to the top with a beautiful view of Fujisan and the city below. I was told if I put a coin on its edge, it won't move in this elevator. Easier said than done. But it is a super smooth ride and still, in 2025, the fastest in the world going down. The same 40 seconds up or down.
速度を上げるとき、そう大事なのは上げるだけじゃなくて止めなきゃダメだ。これですね。
Going down too fast, people feel weightless, unsafe. It's why we don't see the speed war on elevators going down. Japan's speed challenge started with Tokyo's first skyscraper in the 1960s, the Kasumigaseki building. Hitachi was challenged to double the fastest speed at the time, 300 meters per minute or 11.2 miles per hour.
霞が関の時代の技術を使って、さらに磨いてですね、世界最高速に持っていくっていう意味では、技術的に何をしなきゃいけないかってインスピレーションは、ありましたね。
They built its first 90-meter high test tower in 1967 to hit that target, now the old research tower. Inside the G1 Tower Test Center, the original Kasumigaseki building motor, rope, and pulley system is on display as a reminder of the team's challenge back in the mid-60s. The Kasumigaseki building was a marvel when it was first built in Japan. There were no tall buildings because of Japan's building standard law, mandating no more than 31 meters, 101 feet in height. When that changed, so did the skyline. So did the demand for elevators. The 1968 Tokyo skyline was a lonely place. And today, the Kasumigaseki building is almost hidden by progress. 36 stories in Tokyo's Toranomon area is not much anymore. The elevators today have been upgraded for comfort and style. Japan's fastest elevator was a huge inspirational win for Hitachi, but it wasn't the world's fastest at the time. In New York, in the 1930s, the Empire State Building had that record until the RCA building, aka 30 Rock, took it over. It would be decades until it was broken again, though Japan was catching up with speed with its American rival. Hitachi hit another Japanese speed record in 1974 with the Shinjuku Sumitomo building, 540 meters per minute or 20.1 miles per hour. For a few months, this 211 52-story building was Asia's tallest tower. Now, like the Kasumigaseki building, it's surrounded by taller skyscrapers in Shinjuku. But the elevator speed record belonged to the United States at the formerly named John Hancock Center in Chicago. 550 meters per minute or 20.5 miles per hour, going to the 94th floor in about 38 seconds. In 1978, Japan finally surpassed its rivals to claim the world's fastest elevator at Ikebukudo's Sunshine 60 building in Tokyo, with elevators going 600 meters per minute or 22 miles per hour. And Japanese elevator manufacturers have dominated the speed world record ever since, taking on the speed challenge in new markets around the world.
大体ですね、ビルの高さが高いのってエレベーターって速くしなきゃいけないんですね。でそれに対して、大体40秒ぐらいで、例えば500メーターのビルで、お客様の利便性考えて到達させるためには、やっぱりその1260メーターぐらいの速度が必要だということで、もともとチャレンジする意欲はあったんですけども、ただ実際そういうことを考えている中で、実際にその広州の、案件で、そういう世界最高速やれる案件が取れたということで、それはもうびっくりしましたね。はい。
Under construction super tall skyscrapers like the 1,008-meter, 3,307-foot tall Jeddah Tower in Saudi Arabia, 168 floors, will need an elevator system, and at great heights, physics presents more challenges with speed inside a building. Japan's technology for speed has gotten better, as seen in improvements in horizontal travel with the Shinkansen. An experimental bullet train reached 443 kilometers per hour, 275.3 miles per hour in a 1996 test. Superconducting maglev, or magnetic levitation technology, can propel trains 603 kilometers per hour, 375 miles per hour in trials. So the limits of practical horizontal travel seem likely to increase. That technology might make its way into elevators one day if safety, comfort, and practical operation costs can be achieved. Apart from height, there is also shape. The taller a structure, the more the need for an elevator there is. The Ushiku Daibutsu is a massive 100-meter tall statue, too tall for just stairs, so Hitachi installed elevators here. This one is an unusual shape going to the observation deck. It's an amazing challenge each time, as well as going vertical in style. A lot has changed over the last 50 years. Buttons are touchless, gesture controls, digital experiences, more relaxing lighting, and better accessibility.
Just here in front of Tokyo Station, if you look around, the amount of tall skyscrapers that has increased at a rapid pace over the last 5-10 years.
Tokyo skyline is increasing again. The Torch Tower will be completed before 2030 with more super talls on the way. With more super tall skyscrapers planned, inevitably a reason to go faster will present itself in the near future. Safety is essential with speed, especially in an earthquake-prone country like Japan. The world's fastest elevator underwent a drop test and has an emergency stop device that prevents it from hitting the bottom even if the ropes have been cut. Every passenger's worst nightmare. But a place like Japan has more challenges for elevators and super tall skyscrapers. What happens if an earthquake knocks out power? I tried out a simulation of new elevator safety technology. It happened suddenly. The elevator stuck between floors.
It's a real sudden jolt. Alright, we've lost power in the elevator. I'm kind of between the floors here.
If this were to happen all over the city, it would be hard to evacuate all of them in a timely manner, so backup power and computers assess the situation and take you to the nearest floor. Should backup power not be available in a disaster, the use of an EV car battery can generate enough power for an estimated 15 hours in a pinch. This EV car's battery is quite powerful and can be used to do more than just power itself to drive. Clicking the button on this unit, it reverses the power to the generator and the elevator inside the building using an efficient low speed, and it'll safely evacuate people and help them back until power can be returned. When it comes to raw speed, rivals are gearing up, but it seems Hitachi is ready too.
またチャレンジくれたらやはり絶対。
はい、それはもちろんです。はい、スピードだけではなくてですね、やはり人とかビル、あと社会ですね。社会のニーズにどう応えていくかですね。
After speed and safety, the challenge is efficiency, and even more than that. Bigger elevators can take more people, but it can't go as fast. Each building has specific needs to cater to its owner's needs. It's more than just raw speed. A popular building might want to decrease waiting lines, so a balance of speed and size is needed. Elevators are becoming more digital, adding in effects, sounds to make the ride more seamless in everyday life.
Alright. Wow.
This elevator at Shibuya Sky in Tokyo makes it seem like you're teleporting through space to a new world, enhancing the attraction's appeal. It seems likely elevators will get faster, go higher, solving the problems of ear discomfort and weightlessness with new materials, tech, and physics.
でも最後は度胸ですけどね。度胸というか自信ですね。やっぱり自分の自信、これが最後絶対必要になります。はい、度胸じゃないな、自信ですね。
Hitachi won the contract for this elevator in 2012, and the team worked hard to reduce shaking, noise, weight, and ear blockage from pressure changes. No small feat. Here's a list of the Guinness World Record world's fastest elevator since 1931. It's not easy to level up. Each new fastest elevator requires rethinking past experiences with new materials, solutions to speed up safely. And finally, installing those very heavy, very powerful motors atop super tall skyscrapers is itself a challenge. The world's fastest elevator to date started installation in 2014, and when completed in 2019, travels from the ground to the 95th floor in 43 seconds. Talk by competitors of Hitachi to break that record is increasing to break the 50 mile per hour or 1,341 meters per minute mark. Hitachi remains the champion and ready for any challenger to that record. It seems the limits of vertical travel has yet to be completely decided, although it seems like we're getting closer.
I hope you liked it. If you did, hit that subscribe button and join me in another adventure as I take you to every corner of this amazing country. Mata ne.